Bella, we are here waiting for you. Since you are the first person here, please you unmute and then give us an opening prayer.
Okay, Father in heaven, we thank you for this day. We thank you for the lesson. We pray, Lord, that you will forgive us all that you have done. We have done that has made you happy. And I pray, Lord, that you may make this lesson a success. In the name of Jesus Christ, I pray. Amen.
Amen. Thank you so much. And okay, so as we go through our class, Joshua, you'll give us a closing prayer. So you prepare. You're also the other person who was here early enough. So you prepare as well. You'll give us a closing prayer somewhere when we close for today's lesson. So be ready for that. Joshua, you'll be the one to do so. Okay. So members, I want to welcome you once again for our class that we are going to wind up as far as this is concerned. Now, for those who are just coming in, we've been looking at the indices. We've been looking at the indices, and we looked at the different laws of indices. Now, we said when we look at the indices, we are looking at powers, okay? In short, we are looking at how do we deal with numbers that are having powers. So we had different means through which we would work out the numbers and how we would try to sort the powers. And we looked at a couple of laws as far as the indices were concerned, whereby we looked at our first law, which said that when you are multiplying numbers of the same base, you add the powers. Whereby we give an example, if you have a to the power m times a to the power n, we said here what you do, you say a m times the n, then you will get your answer there. Then somewhere we also say that when we are dividing numbers of the same base, what do? We subtract the powers, okay? We subtract the powers. So in so doing, we shall have a m minus n. Class, these are the basic principles that we need to get as far as our indices are concerned. Once you get these principles here, then be very sure that you're going to work out the rest easily, okay? Then we also had a rule that say that when you have a power raised to a certain power, okay, a power being raised to a certain power, you multiply those powers there. So here you have m times the n. If you have a power raised to a certain power, you definitely have to multiply those powers. Then we also went ahead and looked at, I'm doing this as a summary as we get into our revision as well. I'm trying to put up a summary here. Then also we said when we have a number raised to a negative power, okay, if we have a number raised to a negative power, this one can be as the same as a fraction. We can turn that into a fraction in that given form. Then we also say that when we have fractional powers, like for example, when you have a to the power half, this is the same as, say, the root of a. If we raise a to power a third, this is the third root of a. That is what we do have. So in our work, these are the things that we ought to remember, okay? Keep remembering this. And when you get a challenge somewhere, please always and always refer to these rules as they do apply, okay? If you do not, then it's going to be very difficult for you to work out numbers as far as the indices. Please, when we talk about indices, we are talking about powers, or another term is called the exponents, okay? So all these words here meaning the same thing. The singular form is index. So wherever you see index, it means we are also still talking about the powers. And remember, we also said any number raised to a 0 is always 1. Okay? So when you get, even if it's a million raised to power 0, the number becomes 1. That is what we do have. So as we get into our revision, these are things that we ought to have in mind when we are working through. Okay. Now I marked most of your work, and by the way, some of you, hey, give money to the best student. Hey, okay, I need to look for that money and I give the best student. I don't know who the best was, but I had several people with good marks. And a few of you were unable to try to complete your work. You see someone solving a number and ends on that way. So that is something that he tried to mess people up. And I'm sure when you check in your Google Drive, all your results, Google Classroom, all your results are there. So you try to check. If you've not seen your results, please go check in the Drive, the Google Classroom, and then you'll see your results right there. Okay, do I have some concerns before I continue? Sally Henry?
Sir, I just wanted a clarification on rule number 1. You said a to power m times a to power n equals to m, a to power m, and I thought it is okay.
Plus, we add, we add the powers. Good, thank you. We add the powers. Okay, Winnie. Yes, Winnie.
So I am asking, is this mathematics?
Yes, this is mathematics.
Okay, sir, thank you.
Noelle?
Excuse me, sir. I'm new here, like for the math lesson. I just wanted to ask, like there is somewhere you say that like a number to power 0 is 1. Why?
That is a rule. It is a rule. That's what it's supposed to be. But when you raise, it's like you're multiplying, it's still that same, it's just 0. That's how the rule is. When you raise anything to power 0, it remains that. Okay, Timothy? Yes, Timothy? Okay, Timothy is not there. Okay, so let's proceed and go directly to our work directly on what we are supposed to revise through. Okay, let me share something here that we are going to show as an illustration. Okay. So these were the numbers. I'm going to go through one number at a time as we work out together. And where you find issues, please you raise up and then we try to correct through. So this was our number 1. Yes, Sally Tendo. Tendo, sorry. Tendo, Brenda.
Teacher, on rule number 3.
We are going to see them in the revisions here. Yes, Sally?
I just forgot to lower my hand, sir. I have nothing to add on.
Okay. All right, so let's continue. So we had these numbers. This is what we had as our number one, and we were supposed to solve this and come up with we're supposed to simplify this and then come up with an answer. Okay, now as I said, remember we are dealing with the powers. Okay, and whatsoever we are doing in reference to the powers. So when we have something, a number like this, the very first thing we need to do is try to put these numbers in brackets in the form of powers. We first simplify them in the form of the powers. That's the very first thing that we need to do. Please don't go directly. I saw some people going directly with their calculators and then dividing. We don't do that. Okay. Okay, so what we do, let me show you something here. So I said these ones here, we first simplify them. Yeah, I don't just go and divide. Some people are doing the direct division. Okay, so for example, when we have 125, what is this one in power form? What is this in power form? 125 in power form. We are going to use the chart. Can we type? What is that one? Okay, maybe someone to raise up the hand and tell us. Yes, Craven.
It's 5 power 3.
It's 5 power. Craven is 5 power
3.
It's 5 power 3. Then how about 8 in power form? Still we have the Craven.
It's 2 power 3.
It is 2 to the power 3. Good. Thank you. Another person to give us, yes, Atino. Atino?
Yes, teacher.
So what is 25 in power form?
5 to the power 3.
5 to the power 25.
Yes.
Are you sure it's 5
No,
to the
5
power
to the
3?
No. 5 to the power 2.
5 to the power 2. How about 16?
2 to the power 4.
2 to the power 4. Okay. Are you sure? 16 is to the power 4.
Yes.
16. Okay. That is if you're sure of it. Another one? Sally Henry?
Yes, sir.
Sally Henry, are you there?
Yes, I'm there, master.
So what is 625 in power form?
5 to power 4.
It's 5
To power 4.
to the power of 4.
Yes.
Then 64.
2 to power 6.
It's the same as 2 to the
To
power
power 6. 6.
to the power 6. Thank you very much. Now, members, once you do this, then be sure you're now working with the powers. Okay. So from here, you now do the substitution. We now do the substitution. So this meaning this one is the same as we do the substitution 5 to the power 3 out of 2 to the power 3. Okay, all this in brackets 1 out of 3 times 5 to the power 2 out of 2 to the power 4. All this into the power of negative 3 out of 2. Then times, we have 5 to the power 4 out of 2 to the power 6. And all this is the power of a half. So this is the very first mark. This is why you're going to get your very first mark. Okay? Doing this is where you get your very first mark. Okay? Doing just this. Now, from here, remember our rule that says that when you have a power raised to another power, you multiply. Okay? you multiply the powers. For example, we said if you have a to the power m in brackets power n, this is the same as a m times what? Times n. That's what you do. So we do the same thing here. So what you're going to do now here, you're going to multiply. So you're going to say, remember this third here multiplies everything, both up and down. Some of you were only doing the bottom part of it alone. So we do this. So we say 3 times 1 out of 3, out of 2, 3 times 1 out of 3. This is in brackets. Times 5, 2 times negative 3 out of 2, out of 2, 4 times negative 3 out of 2. We put all this in what? In brackets. Times 5 power 4 times 1 out of 3, sorry, 1 out of 2. Then out of 2, 6 times 1 out of 2. And we put that in brackets. Okay? So this is what we first do. Okay? So from this point, you start solving it now. So whereby you reduce them now, like this one is once, this is once. This one is also once, this is also once. I saw some of you doing this. Okay? Then you're trying to reduce this once, this is twice, this is 2. Then this is once, this is 2. You're trying to reduce this down. This is 1, this is 3. Okay? So you rewrite your result again. So when you rewrite, you're going to get 5 to the power 1 out of 2. This is also to the power 1. You may write the power 1, you may not write it as well, but it's okay. Then out of 5 to the power, this will be negative what? 3. Out of 2 to the power, 2 times negative 3, we get negative 6. Times 5 to the power 2. Because we say 2 times 1, out of 2 to the power 3. This is what we do have, okay? Now, in our rule, or when we are multiplying, okay, so when we are doing our rule of multiplication, we say that what you do, you are supposed, remember, you are supposed to, when you're multiplying, if you remember, you're in multiplication of fractions. When you multiply fraction, you multiply the top alone and then the bottom alone. So, meaning this is going to be equivalent to, you're going to say 5 to the power 1, okay, times 5 to the power negative 3, times 5 to the power 2. All this is out of 2 to the power 1 times 2 to the power negative 6 times 2 to the power of 3. Okay? Now, this is when our rule comes in again. When you are multiplying numbers of the same base, what do you do to the powers? You add them. Okay? That is m plus what? Plus n. You add the powers. You see how our rules are coming in. Okay? So meaning, here we have the same base of 5. Here we also have the same base of 2. So what will this equal to? So here we shall now get 5, okay? Then we add the powers. We shall add 1 plus negative 3 plus 2 out of, okay, 2 to the power 1 plus negative 6 plus 3. Okay? So, therefore, from here we shall have, what will 5 be raised to the power 2? I think this will be 5 to the power. How can give us the answer there? 1 plus negative 3 plus 2. What's the answer there? What's the answer there? 0, 0, 0. So we are seeing 0. Is everyone getting 0? It is 0. Okay. So this will be out of, then how about 2? 1 plus negative 6 plus 3. What are we getting? So which will be 2 to the power. Brian Crystal says -2. Are we also getting -2? Any other person getting the answer? 1 plus -6 plus 3. Kimberly says 8, -2. Gloria says -2. Okay, so our answer here, we are getting negative of 2. Okay, so therefore we know that, remember we said any number raised to the power 0 is what? Any number raised to the power 0 is what? Is 1. We remember that. So meaning the 5 will be equal to 1 out of 2 to the power -2. So this is what we shall be having as our answer. So someone may simplify it further. Okay. Okay. So this is what you're supposed to be doing as far as this answer is concerned. Okay. Let me answer some concerns that was someone may have raised. Yes, Tendo. Tendo? Are you following? I just have been following slowly. I've been moving through slowly.
The second shape.
Where haven't you got?
From the second.
We are saying you are multiplying the 2 powers, this one inside and the one outside. And that's what we are doing in the second step.
And how about the first step?
Pardon?
Have you got that step?
Which step?
The first one.
The first one, we said we are reducing these ones in form of powers. That's what we are doing. The one we did up here. Yes? Okay. Who else has an issue? Yes, Noeline?
Teacher, this part where you said 5 into like the powers 1 plus -3 plus 2. Is it okay if I put it in brackets? Or it's wrong?
This one like this?
Yeah.
It is very fine. There's no problem.
Thank you.
Okay. Okay. Who else? Please, if your device is not named, I may not call you a name. We told you to name your device. Like this one of iPhone 12, someone. I can't tell your name. That's why. Yes, Sherry. Sherry, you have an issue? Yes, Sherry.
Teacher, I was asking that here on the first solution, I didn't understand.
Where?
The first line, that 125, that it's equal to 5 powered by 3.
This is what we did. I don't know if you are following this step here. Please, I want us to follow. I want us to follow keenly on our body here, because when you lose track like this, at the end of it all, we shall keep on dragging. We say the first thing, we have first put these numbers here in terms of powers, and this is what we have done. This other side. I don't know if you are seeing this. Yes. Are you seeing these ones here? We are saying 125 is the same as when you get 5 times 5 times 5, you get 125, which is the same as 5 to the power 3. And this is what we have done this other side.
Okay.
Yes, Ms. Ghana.
Teacher, I just want to simplify this one. The last answer, I just want to simplify it.
Into,
So we have 1 over 2 to the power of -2, yes? Then we do 1 over 1 to the power of 2.
1 out of?
1 out of 1 to the power of 2.
1
over 1 over
This
to the
one.
power of 2. Yeah,
Okay,
we do like that.
you realize that this one sounds more better than this one here. This one
Yeah.
you're putting two divisions.
Then we do. Yeah, we reciprocal it.
Which will come to?
To the power of 2 over 1.
2 to the power 2 over 1.
Over 1. Yeah.
That is all.
Then the answer is becoming to the power of 2, which means 4.
Pardon?
The answer is becoming 4.
It's becoming 4. You're
Yeah.
saying it's, now you realize that just a moment. Now you realize that when you get this 4 here, this 4 is not the same as this 1 out of 2 to the power negative 2. It is not the same. Okay. Remember here with the powers, when you try to work backwards, make sure you come to the same thing at the end of it all. Okay. So that is why we may not go beyond, as long as you make sure it is if it was just 1 out of 2 to the power 2, you'd say this one, this is the same as 2 to the power negative 2. That's how you would put it. Okay. Okay, so members, I think we've got this, and that is how we're supposed to run through this one here. I think that's a bit more clear. Okay, let's move to the next one. We are here. Now, we are saying without using tables, evaluate this, okay? We're supposed to evaluate this without using the tables. Yes, we got our final answer. I think we've seen our final answer. All right. So we are here. Still, we use the same principles. We use the same. First, try to ensure that you make these ones, you put these ones in power in the form of powers. Okay. Put these ones in form of powers. But remember, now that you have 1 out, you know that 1 out of 125 is the same as 125 power negative 1. There is also that thing that you need to have in mind as well, but you can try to. But anyway, let's not move to that as fast. So remember, we first start by putting this one in the form of powers. 125, we say this one is the same as 5 to the power 3. Okay. 9 is the same as 3 to the power of 2. Then you do the substitution. Okay. So when we carry on the substitution here, we shall have 1 out of 5 to the power of 3 into brackets negative 1 out of 3. Divide by 1 out of 3 to the power of 2. Okay. Into the power of 2 out of what? 2 out of 3. This is the very first thing that you need to do. Now, if you do not want to multiply this by each, remember up here we just have a 1. So meaning you can turn these ones into negative power because it is just 1 out of. So we can also say this is the same as 5 to the power negative 3. Remember what we are using is our rules. Remember we said that when you have 1 out of, okay, when you have 1 out of maybe A, this is the same as A to the power negative 1, okay? That is what we mean. That's what we mean. If it is power 2, this becomes negative 2, like that. So that's how we are coming to this point here. Still, we are doing divide by 3 to the power of negative 2 into brackets 2 out of what? 2 out of 3. Okay? So this is a power of negative 1 out of 3. Still, we follow the same thing. When we have a number raised to another power, what do? You multiply the what? The powers. Okay? So what do you do? What shall we have? We shall have 5 to the power negative 3 times -1 out of 3. Okay, this is what we have. All this is in brackets. Divide by 3 into -2 times 2 out of what? Out of 3. Okay, members, all this we are doing based on the laws of indices. Okay, the laws of indices. Please, if you've written these laws somewhere, please follow them. Okay, if you have the laws, then you need to keep following them. It will keep on telling you what you do, what you're supposed to do on the next step. Okay, so we are there now. And so from here, you multiply your powers. So this one goes into this ones. This is 1. So -1 times -1 becomes 1. Okay, because it becomes a positive 1. I hope we know that. When you get -1 times -1, you come to 1. When you get -1 times -1, you come to 1. So this will be equivalent to 5 to the power 1 divided by 3. Here there is no reduction, so it's -2 times 2. -2 times 2 is 4. Negative is -4 out of what? Out of 3. So this will be -4 out of what? Out of 3. Now, a mistake that people are now doing here is now dividing this by this and then doing, you know, it was a bit a mess. But here what you need to do, also avoid putting your numbers in decimals. Avoid putting your results in this. I saw most of you getting your numbers in decimals. Please leave your numbers in fractional form or whole number form or negative power form. It's always more better for you to do that. Okay? So, how do we deal with this? So here what you can do, some of you are leaving it like this, but you can say it is 5 out of 3 to the power negative what? 4 out of what? 4 out of 3. This will be quite more better. It will look a bit more better. Okay? While other people were getting the reciprocal here. Okay? Some people are getting the reciprocal here. Now when you get 3, -4 out of 3, if you want it it can be 1. If you want it to be positive 1 out of 3 to the power 4 out of what? Out of 3. And when you turn it, you can also put it in terms of 3, the power 3 out of 4. Okay? In the reciprocal form, as someone was saying. That's what some people were doing. Some people were getting their answers as 5 out of 3 to the power 3 out of what? 3 out of 4. We do the reciprocal to eliminate the negative. That is how we can also come to this. Okay? But this is this will, please don't again do divide the 3 divided by this, then you get the we are dealing with indices. Okay? We are dealing with indices. When you do that division, you're going to get decimals and the number is going to disturb you a lot. Okay? So the best thing to do is to leave your answer in this given form. It will look up here. So it will be quite more better for you to do so. Okay. Any question on this? Any question on this that I need to clarify? Any question? Yes, Kim. Please go on. Yes, Bella.
What is the ending answer?
It is here where I've put the tick. You can either put this one or this one here.
Okay, thank you.
Okay, okay, yes, Shami. Yes, Shami.
Excuse me.
Oh, Shami, we lost you.
Excuse me, mister.
Yes, please.
Does the reciprocal, does the power also change the reciprocal? Like from 4/3 to V/4?
It is because of the negative. It is because of the negative. That's why we turned it in this form. Okay? It's because of the negative.
Yes.
Okay, Aida. Yes, Aida. Okay, so members, as I said, please name your devices. Okay, so this is okay. Then we proceed to another. So literally, members, the laws of indices still apply to all our results as we keep working out. That is what's more important. All right. Okay, so we have this also. We're told to find this. Whereas it's like putting this one in its simplest form. That's what we are doing. So let's look at A. I said step number 1, put the number in form of powers, the one that is raised to a certain power. We first put it in form of what? In form of powers. So we first say 16 is the same as what? In terms of powers. 16 is in same as what? In terms of powers. 16 is the same as in terms of powers. I need an answer. Yes, Deborah.
2 power 4.
It is 2 to the power of
4.
Okay, so it's 2 to the power of 4. So literally what we shall do, we shall say it is 2 to the power of 4 into bracket 3 out of what? Out of 4. So this will be the same as, so you open up the brackets following the other rules of indices. So we shall have 2, 4 times 3 out of what? Out of 4. Okay? As someone says, you may put them in brackets, you may not, as long as you get to know what you're doing. So then when you reduce this, so this will be equivalent to 2 to the power of what? A power of 3. Some people were putting this, I think they were trying to get, multiply it again. Please, it's advisable you leave your number in this. This is the simplest form. Some people are going ahead to say 2 times 2 times 2, then they come up with it, I think 8 or so. The best would be this one here. You leave it in index form. Don't again multiply it to take it back. Okay, sorry. Don't again multiply it to take it back. Okay, leave it in its index form. That's how you're supposed to leave it. Okay. So it will appear quite more better to have it. This is the simplest form you can put this. Okay? Then we also do the same thing to this. So we say 4 is the same as 2 to the power of 2. Okay. Then 9 is the same as 3 to the power of 2. That's step 1. So step 2, we now substitute. So we shall have 2 to the power of 2. Okay. Out of 3 to the power of 2. All this one is the power of what? A half. Now, another challenge where what people were doing, they were trying to multiply this a half on only either down or up. Please, this a half multiplies both up and down. Okay? It multiplies both up and down. Then I saw some people introducing in the root sign. That's also another thing, but usually when you introduce the root sign, it means you're not going to solve it easily again. So this will be equivalent. Open up there. We multiply the 2 powers. So 2 times 1 out of 2 out of 3. 2 times 1 out of what? 1 out of 2. So when you reduce this, your answer will be equivalent to 2 out of 3. As quick as this. Okay? So this is what we need to get used to. This is what we need to get used to on what we are supposed to be doing. And so in so doing, you realize that you have your answer. This is the simplest form of this number. Okay? This is its simplest form. That's what we are looking at. Okay, any question here? Okay, Sherry. Yes, Sherry. Okay, Aida. Yes, Aida.
Yeah, the second life stage, yeah? No, Ronnie.
Hey, Aida, you stopped on the way? Okay. Yes, Elizabeth.
Teacher.
Yes, Elizabeth.
Good morning, teacher.
Yes, please, morning.
Teacher,
Okay.
can you repeat for me the numbers? B.
So let's
Teacher, can you repeat for me?
All right. Please take F1. I don't know who this one is. I need to know. Please name your device. Please name your device. Take F1. I can't tell who you are. Can you name your device so that I can call you by name? Otherwise, you may not know who is speaking. Take F1. Okay, so this is what we were supposed to be doing as far as that. We can't use the root law. No. We are using this. We are trying to use the what? Please, the issue is use the indices. Province, use the indices to solve this. Don't say now the square root of 4 and 9 is this, then you just say this is a 2 out of 3. In the indices, you're not solving it this way. Okay, so how are we solving this? We are solving this by trying to apply the rows of indices. That's how we are trying to solve this. Okay, right now finally, as we continue, I think we are on to our last question. Now, these ones were about 10 of them. Actually, there were 10 of them. And they were all supposed to be solved in a similar manner. All of them are supposed to be solved in a similar manner. Now, I'm going to solve about, I think, about 4 or 5. And then from there, I will let you solve the rest, as long as you know the methods of how to solve it. Now, 1. Let me start with the first one here. Yes, Kim?
May I solve that first one?
Okay. Please do. Okay. Kim is going to solve for us this to help us in solving this. So, and we get started with our solution.
So I'm just trying.
Please do. Please do.
Okay. Base 2. Then to the power, like, because here that's a multiplication, we are going to add those powers up. 3x.
3x.
Plus 2x.
Plus 2x.
Is equal to 2 power 8.
2 power 8.
Yeah. Then when we add 3x plus 2x is 5x, so we say 2 to the power of 4x is equal to 2 power 8. Now, there, help me, sir, there.
Okay, thank you, Kim. So from here, what we do, Now, why are we doing this? It's because all our bases are the same, okay? When you see that your bases are all the same, this is what you do. On this other side, we try to add our powers. Then this side, we maintain our base there. So therefore, what we do, you equate the powers. So meaning you equate the powers. So meaning our 5x will be equated to 8. Then you divide through by 5, you divide through by 5. What are we solving for? We are solving for x. Okay? So meaning your x here will be, sorry, your x will be equivalent to 8 out of what? Out of 5. Okay? So what are we doing? We are equating the powers. Since we have the same base, we also equate the what? We also equate the powers. Since we have the same base. Okay? That's how we try to work out. And you know, most of you were ending at this step here. I don't know why. Most of you were ending here. When you stop here, you've not solved for x. Okay? Okay, on this note here, yes, Sadi.
No, I just wanted to solve the next one.
Oh, okay. You're solving the next one. Okay, you're going to solve. Let me first answer some people's queries here. Then we come in with, yes, Sherry, you have a question? Sherry?
Now, teacher, what if those ones down when they are not the same?
Now, when they are not the same, that means we are solving something else. Okay, we are now no longer in indices. We shall find another way of solving it now. But here, it only works for same powers. Okay. Liz?
Teacher, why haven't you continued and divided the 5 by 8? The 8 by 5.
Can you reduce 5 by 8 again?
Okay, so 8 by 5.
Can you do it? What do you get? Oh, now I understand what you're saying. Okay, I understand what Liz is saying. Now, like most people were doing, they were saying, they're going to their calculators and saying 8 divided by 5, and they were getting 1.6. I think this is what Liz was saying. Now, members, I suggest that we leave our numbers in fractional form, okay? Yes, I was marking most of you, those of you who were converting this and then putting their answer in this, it is fine, x is 1.6, okay? But it's advisable, please, you try to leave your answer in fractional form, it's quite more better. But even these ones, you have been marked. I was marking that given number, those of you who were putting it in terms of this. I think this is what she was meaning. Okay, Noeline.
So, sir, like after this part of getting 8 out of x is equal to 8 out of 5, what do you do about this? Do you just leave it like that, or you do something about it?
The what?
These two, like 2, 5 here, yeah. Where, yes. So you came here and you said when you have the same base, we equate the powers, and you got 8 out of 5. So what about this 2?
No, the 2 is already equated. It is already the same. The 2 is already the same. You cannot again, when you equate 2, you want to say 2 is equal to 2. Then you stop there. Remember, our aim is to solve for x. Look at the question 2. The question wants you to find the value of x. That is what the question wants you to do. But this 2 here is helping you to know that this one is equivalent to this. So therefore, you can equate this to, since this is the same, meaning you can equate the what? You can equate the powers, and then you come up with your value of x. That is what it is guiding us to do.
Thank you, teacher.
You're welcome, please. All right, so finally, let's see, wind up with this. We have 5 minutes to go. Now, in these numbers, we also do the same thing. There is one I want us to solve. I think it is this one here, number 3. I want us to look at number 3. Who was saying was Sally Henry. Sally Henry, are you there?
I'm there.
Yes. So I'm going to leave this one for members to finish it. Now I'm going to number 3. We are solving number 3.
Into black, y to the power 4 into 3x.
Yes, this is it.
Then you close the bracket to 3x.
Yes, this is it. This is what you're mentioning. What do we do in the next step?
So, since we're looking for the value of x, I think we shall go with 3x plus 2x equals to 8.
3x plus this. No. Now, the first thing we need to do, first of all, let's start it from there. The first thing we now have to do, we need to first open up the brackets here. Remember, these are powers, okay? And we said when we have a number raised to a certain power, you first multiply the power so that we get them to be the same, okay? So therefore, to do this, you need to first multiply 4 times 3x times y, 4 times what? Times 2x. What are we doing? We are first opening up the powers. 4 times what? Times 8. So when you do this, you'll get y, 12x times y, 8x is equal to y. I think this is 32. 4 times 8. So you get this as 32. Now from here is now when you do what? You do the equating of the powers. So what do? You'll get your y, you first add the powers, 12x plus 8x is equivalent to y, 32. So when you get 12x, 12 plus 8, we'll get the 20. So y, 20x is equivalent to y, 32. So equate the powers to be able to get your value of what? Your value of x. So 20x is equivalent to 32 out of 20 out of 20. So when you reduce this, you come to x is equal to, you can also reduce this. Some of you were doing that. Maybe by 2, 16, by 2, 10, and again by 2, 8, by 2, 5, I think. Yes, I hope it is that way. So from here, you'll be able to get your 8 out of what? 8 out of 5. This is your value of what? Your value of x. Okay. Now, remember our laws of indices are still applying. We are not leaving them behind. So step 1, make sure these powers have been simplified. You open up that bracket and then you solve, then you equate the powers as well. So in so doing, you'll be able to come up with your results. Then same thing still here, subtracted. Here we subtract the powers. 3x minus 2 is equal to 8. Okay, so 3x minus 2 plus 2 is equal to 8 plus 2. So 3x is equal to 10 divided by 3, divided by 3. So your x will be equivalent to 10 out of what? Out of 3. What are we trying to do? We are trying to use the principle of equating the powers so that we can be able to come up with our result. So what you do in number 4 is what you do in number 5 as well. Then this is also the same thing. Okay, please be careful. Where there is a negative, carry the negative. If it is 2x minus minus, please leave this minus there. It is minus 3 equal to 8. So when you minus, this one becomes a plus. Okay, so we shall have 2x plus 3 minus 3 is equal to 8 minus what? Minus 3. I've already equated the powers. 2x is equal to the 5. I think it becomes 5. Okay, so divide by 2, divide by 2, x will be 5 out of what? Out of 2. The point is, please carry your negatives. Don't leave the negatives behind. Okay, so the same principle used on 6 is the same we use on the 7. And maybe there is one which was challenging. I think it's this one here. Let me finally work out 10. I think we are closing. So here still what we do, remember, still look at your base. The base is still the same. But this power here takes on everything here. So what do? You first open up your brackets. Meaning this 2 is going to multiply with this, and this 2 We multiply by this, and it will also multiply by this other one too. So you will have 1 out of 20 into brackets 2 into 2 plus x times 1 out of 20 into 8x times, okay, 8x times 2. Maybe let me use a dot for the times 2. That's what we have. See, it is equivalent to what? To the 1. Okay? It is equivalent to 1. No, sorry, it is equal to 1. This is 1. Huh? But then we know that when you open up the brackets, so we have 1 out of 2 into brackets. When you open these brackets, it will be 2 times 2, which is 4, plus 2 times x, which is 2x, times 1 out of 20, close brackets. This times this, it will be 16 what? 16x. Now, remember, how do we try? Remember, we are trying to use equivalent fractions. How do we turn? We make sure we turn this one here in form of this 1 out of 20. But remember, we say that any number that is raised to the power 0 becomes a 1. So how do we come to this? This is the same as 1 out of 20 to the power of 0. This is how it comes to the 1. So we do the substitution here. So this is equivalent to 1 out of 20 to the power of what? To the power of 0. Why are we getting the 0? The 0 is got from this principle of the indices, that when you have a number raised to the power of 0, we shall come to this 1 here. So you do the substitution. So once you now have the bases are now the same throughout, you now equate the what? You now equate the powers after adding this. So here we shall have 4x plus, 4, not 4x, it is 4 plus 2x. Remember here we are adding the powers, plus 16x is equal to what? Is equal to 0. So here we shall have 2x plus 16x, we shall have, that is 18. So it is 4 plus 18x is equal to 0. So you take the 4 the other side by subtracting. So in so doing, what you will get will be 18x is equal to 0 minus 4. So 18x will be equivalent to negative 4. So you divide 0 by 18, divide by 18. Please, you can reduce down. You may also leave it that way, okay? But it is fine. So this is how you come up with your result. I know the challenge may be coming from this to this. Huh? This is where the challenge might be. But get to know the principle of raising a number to the power of 0. That's how to be coming up with. Okay. Our lesson is done, unless there is a question. But okay. So, okay, those of you who have not yet registered for the online bit of it, you can try to use that form which is there, and then you can be able to follow up. Okay. Mr. Otto, are you there?
Yes, Teacher Jones, I'm here. I would like to thank you so much for taking this student through the pilot program. I know this one will be our last lesson of the pilot programs. You have been amazing, really. I've been following your lessons from A up to Z, and I can now do indices very well. To the rest of the learners, we're not ending the session. We just really want to reorganize ourselves and become back stronger, like what they said yesterday. So meanwhile, you'll be at home, continue visiting Google Classroom, Colibri Studio, all the platform where we shall be putting our work. So don't be redundant. Continue practicing maths, continue practicing physics, biology, chemistry, and all the subjects, because you may go back to school. And how will you go back to school? Will you go back as a third student, or you'll go back as that student who has been doing lessons online? So you should get some takeaways. When you go to school, at least you'll also be narrating to your friends how you did exams online, how you studied online, and the knowledge that you acquired, how to use these gadgets. So I don't want you to take it for granted. This 1 week or 2 weeks, wherever it will be, please take it seriously. But thank you so much for attending the lessons. May God bless you, Teacher John.
All right, thank you so much, Mr. Top. And to the rest of the learners, please try to go through. I'll be sending more work in the Google Classroom where you'll be able to keep on reading and then working out more work. So try